Thanks everyone for attending this presentation today. I plan to talk for a little while, probably about 40 to 45 minutes, about the implementation options for microservices. The agenda, I'm going to start with a brief bio and share some experience so you know a little bit about me. And then we're going to talk about the history of microservices and even before how we got to microservice architectures and what made them attractive. And then the main event for the presentation is the implementation options and the pros and cons. We're going to focus on two of those, which we'll see here in a little bit. And regarding those two, we're going to have some cost analysis because sometimes, it's not good enough to get something to just work. If you can get it to work effectively and more cost effectively, it's a winner. Then we'll have some conclusions and I'll open it up for Q&A after that. About myself, I've been at Gap for a little over 2 months now. I'm the Chief Innovation Officer. I've been using public cloud since 2013, mainly with Amazon AWS. I have exposure and I have used other clouds, but not nearly as extensively as Amazon. I've gone from on-prem to public cloud to hybrid cloud. I refer to hybrid cloud as the promised land, the one that when companies can leverage their on-site infrastructure and then burst to public cloud providers as they need additional capacity, that is the sweet spot for many of these organizations, what they're trying to do. I've created monolithic apps and I've converted those to microservices. And I've also developed microservices, more of a greenfield type new development, 12-factor apps type thing. I've gone from no containers to serverless. And we'll see a little bit more about that later in the presentation. And I've built some highly scalable apps for publicly facing products and services. We're talking millions of concurrent users on some very popular things like video games. A lot of you have asked me, the ones I've met, which games that I worked on, and I thought I would share that. So I've had significant role in these. Star Wars: The Old Republic was the first one. Then we have the Mass Effect series, Dragon Age Inquisition, and Anthem. I also did a lot of work on the Battlefield series for EA and some FIFA work as well. But my primary titles with me in the credits are those games. And you might say, are there microservices in games? Absolutely. So we'll talk more about that a little bit later. Okay. When we look at a common monolithic application architecture, it looks like this. And this is no surprise to anybody on the call here. We have a front end, web or mobile, typically in JavaScript with frameworks there. It connects to an app server. We'll say that's Java implementation there. And the app server connects to the database. And relational databases have been popular for many decades, and Oracle is also a popular one there. So this is a very common monolithic application architecture that we're trying to break away from for many reasons. As we look at this monolithic architecture, we have services or features or functions that are living and reside in the application server. So in the case of a game, for instance, on the app server, we would have the guild service or the friend service or the leaderboard service. For us to actually make changes to these and deploy these in a monolithic architecture, we have to deploy the whole thing. In order to scale one, we have to scale the whole thing. So it gets to be really difficult to manage this big behemoth application when actually we want a more surgical approach to doing so. So what are microservices? And I'm starting with this background of microservices just so we're on the same page before we talk about how we would implement them. They're small, they're focused usually on one thing. They do one thing and they do one thing very well. They're autonomous, they stand alone. One does not impact the other. They're stateless in nature. Is the author of a book on a high scalability wrote, rule number one is be stateless. If you can't, stay at rule number one. The next one is they're resilient. so they can go down and pop up and not have any impact on availability. They are highly scalable because we'll see how we can have multiple of the same thing in operations at the same time. They're heterogeneous. So this is one of the main advantages of microservices. The developers of the service get to choose the technologies that the service is implemented in. And so instead of in the old days or the prior slide where we had a big Java implementation on the app server, we would hire Java developers. In a microservice world, the developers get to choose, and you can choose to limit the list of languages they can pick from. But instead of just being a Java shop, you would actually say we use Go, we use Python, we use Node. And that way you don't lose out on some really talented developers who want to work in languages that is not your primary one. Last but not least here, it's no silver bullet. So there are a lot of advantages to using these, but they come with some additional complexities, in my opinion, that are worth it, but it's not a panacea or a silver bullet by any means. So if we go back and we start to break away from that monolithic application and create a microservice architecture, notice here that we have the guilds service, which is separate, and that's written in Node. And then we have the friends service, which is separate, and we'll say that's written in Python. And leaderboards, in this case, we'll say it's written in Go. In front of these, we have the API gateway, and that's just routing traffic from the request to the endpoint of that service. But still, these services are hitting the main Oracle database, which means that they're not quite there yet as far as being a full microservice. And when we talk about them, especially at this level, we're talking in the middle tier, back-end functionality. Could you have microservices at other layers in the architecture? Yeah, but it's kind of unusual. So we're mainly talking server-side functionality here when we're talking about microservices. So the interesting thing here is we have no app server anymore. It's gone, but we still have a shared database. So this is why we're still on step one of creating a microservices-based architecture. When we ask ourselves, can we develop, build, and deploy services independently? Can we scale services independently? If we look back at this picture, when we ask those questions to ourselves, the answer is no, we cannot. So what would we have to do in order to be able to answer yes to these questions? Well, the key here is to be a full microservice, it has to be completely autonomous. So for the guild service, for that to happen, it needs to have its own persistence layer. So guilds has its own database. We'll just say that's relational. Friends has its own database. We'll say that's a graph database, which makes sense when you talk about relationships and hierarchies and things like friends lists and things like that. Graph database would be suitable for that. And then our leaderboard implementation, which is written in Go, it has its own persistence layer, its own database, which we've chosen to be NoSQL. So there are a couple things here. One is notice that the persistence layer is tied to that service. So it doesn't have to be the same. We don't have to have the same kind of persistence for each, whatever makes the most sense for that service. Also worth noting is what if in this scenario, our friends service wanted to access guilds. So I need to know what guild my friend is in. That would be a logical question or service for it to ask. Well, it does not do database access directly. So this is like the cardinal sin in microservices, because if we had this dependency here, now I'm not completely autonomous. I can't deploy and scale this thing independently because I have things, other services hitting my database directly. So the proper way to do that would be the friend service asks the guild service for information that it needs. And it could either do that through the API, or maybe there's a queue implementation or something. But accessing the database directly is a no-go in a microservices world. So let's ask ourselves again, can you develop, build, and deploy services independently? Can you scale services independently with the picture that we just drew? Yes. So now we have a microservice architecture. This is a common question when going from a monolithic application to a microservice architecture. Isn't managing one thing easier than many? Yes, it could be, but not necessarily anymore. So it used to be, before we had things like this public cloud, these robust implementations and these ecosystems of services that we become as developers, the stitchers of all these things that make it so easy. Also, before we had containers and container orchestrators, and before we had robust CICD. So, 10 years ago, microservices much more challenging. Now they have actually promoted the growth of these things, and so it has made it much easier. I believe, this is an opinion, that the benefits far outweigh the challenges. Now, if you have a monolithic application, and I've run into many customers that do this, and they'll be apprehensive about going to a microservices architecture. And a good reason not to go and make any changes is because you have no changes to the application that are required. So it's a legacy app. It's in really no maintenance mode. You're not having some of the challenges that you have to deal with in maintaining a monolith. And so you just leave it alone. I totally agree with that strategy. It's only when you want to be quicker and you want the benefits of those microservice architectures that you would warrant the actual movement to something like that. Stateless is the key. So to scaling, to managing, and to monitoring. So the first step is we have to make sure that we build things and design things in a stateless way. And the question is, well, how do you do that? And this has been a challenge for some developers in my career. The bottom line answer is you do it differently. You have a different mindset on how you would design something and how it would operate if you have to design for stateless. And I'll give you an example. It's one of my favorite ones. I have a friend that works at Amazon.com. And here's a stateful example from a merchant we're all very familiar with, probably too much so. Amazon.com over here, we place our order, and then behind the scenes, Amazon would check our credit card and notify the user, us, if it was good or bad in the user interface while we were there before we leave. Sounds like a reasonable experience, right? The problem is this doesn't scale. If we had a massive amount of load and we're hung up on credit card checks, then we're getting backed up and we're never able to catch up, and then certain services start to fall over and things get really bad. So I can tell you it doesn't work like this because I know from my friend how it does work. And it works like this. Let me move this guy out here. So everything is the same up to this point. You place an order. Amazon then says, I'm going to put that order in a queue, and I'm going to notify you right away in the user interface that the order was placed. Meanwhile, we have workers that are taking items off that queue and they're processing those. So they can do these at their own leisure. And then they're doing a check of the credit card and actual order fulfillment. If there's a problem, let's say your credit card has expired, you will get an email. Might be 5 minutes, it might be 10 minutes, it might be 15 minutes later to notify you of the problem. So it's happened to me multiple times when using a different credit card or my credit card expired. They did not tell me when I placed the order, and we can all thank them for that because that is how they scale. And they put the order in the queue, and if they need to create more workers because they have a surge in activity and a surge in orders, they just create more workers. And that's how they scale out, and they can do it pretty linearly as a result. So the interesting thing about this is web designers talking about a different mindset. The user is not going to get notification that their order is successful if there's a problem. They will not get notification if their order has a problem with something like an expired credit card. Many web designers would say that's a bad experience, but the reality of the situation is it's not a terrible experience to get notified a few minutes later, and that is how they're able to scale. So that's kind of a trade-off that you have to make, and it's a different mindset in doing so to building these applications that are stateless. Because when we talk about implementation options, assumption number one is going to be these are stateless. By the way, in looking at this diagram, what do you think would be the microservices? That would be one, that would be one, this would be one. All of them except this process here, notify user in the UI, but all these others would be microservices. I wanted to put this quote in because I like it a lot. The best software architecture knows what changes often and makes that easy. So when we design things, Paul Clements wrote a good book on software architecture, and it kind of reminds me that the best way to do something, the best way to design it is really focus on things that change a lot and making them easy. And that's what we're going to take under consideration on our implementation options. Okay. Now we have our background on microservices and the importance of being stateless. And now let's talk about some different implementations. The evolution. So we've gone from a world in which there were no containers, and we didn't know what we were missing at the time, but we had what we like to call dependency hell, and there were no portability for our applications. Well, limited portability. If you wrote on Java, then obviously wherever the VM was that you could run. But encapsulating all the dependencies was very challenging and created administration nightmares. Then we went to containers. Docker popularized those. They existed before Docker made them really popular. So now we're like containerizing our applications. Our dependencies are all encapsulated in our container. And we are so happy because containers for the win. My life is so much better now, and I like everything about them. Then we're at the point where containers are out of control. I went from containerizing a single application to now I have thousands or hundreds of thousands or millions. And when we say millions, it's not uncommon. You know, Google itself, the Google search engine has, I think, billions of containers. But I can tell you that the Anthem game release on launch day, we had 2.8 million containers deployed around the world for game servers. So they can easily get out of control very quickly. And then we're faced with how do we manage these? I have so many of these things and I don't know what to do. Somebody please help. Next in the evolution are the orchestrators. So Kubernetes is awesome. I think everyone on this call understands the value of having the Kubernetes keyword on your CV. It is the hottest thing and the most popular thing going right now. But at the same time, it's hard. And learning it takes a long time to get really good at it. And managing clusters is not fun. So it's complicated, it's hard. There's a lot to it, and there's a lot of different things to be considering when you're managing these clusters that people are overwhelmed with the number of options. And that leads us to serverless, more of a no-ops approach where people are like, I'm more of a hands-off. I just want to focus on my application and not managing the infrastructure required to do so. So for the rest of this presentation, we're going to focus on containers versus a serverless approach to implementing microservices. And we'll start with containers. So just for a quick review here, container compared to a virtual machine, the main thing is the virtual machine has the hypervisor, the container does not, and the virtual machines have guest OS in each VM. The container has a host operating system and it's container runtime, but the apps just have the application. In each container just has the application and any library dependencies associated with that. So an easier way to think of this guy is much more lightweight to be deploying and managing than a virtual machine. But in the market today, I can tell you that with pretty good confidence that the vast number, 90% of implementations these days are still on VMs. So a lot of customers are wanting to get more of this flexibility with the container architecture, and they're trying to move away from virtual machines. So that's it at a very high level. If anyone wants to chat at a later time on more deep dive on containers, I'd be glad to talk to you. A simple sample container CICD looks like this. You have your app repo, you would have a code check-in, it would build and it would produce a container image, and that image is pushed to a container registry. This registry is new in our process here. We didn't have to worry about that before we had containers. So it's pushed to a registry. And then our environment is monitoring the registry, and it notices there's a new version of our app there, and it does a pull and a run. And next thing you know, your app is deployed in your environment. In this case, it's dev environment. It could be any environment, or you could also have a graduation process to go from dev to test to prod. But the main thing that's different here in this pipeline is that you have a container registry where you have these images, and then your environment pulls and runs from there, which is pretty nice. Some of the benefits of containers: dependency encapsulation. For the Node.js developers, you know the number of libraries can be considerable on a particular application. So having that dependency all encapsulated is really, really nice. It enables you to move it around, with our next bullet being portability. Once in a container image, I can toss that thing around, and any place I can run that container, it will run exactly as it is. So I don't have to worry about this thing has different behavior running in AWS versus on-prem. If you can run it, the behavior will be the same. They scale. So the fact that I have this stateless, I can create a gazillion of these things, or I can create just a handful of them if I need to, but we can scale them up and down depending on workload, or we can have our cloud provider have its auto scaling rules in place and make it easy. The next one is manageability. So they're ephemeral in nature, and this is also a culture change or a mindset change as well. So that in the world of containers, we're focusing on killing instead of nursing. So in the old days, if we had alarm going off on a dashboard, or some part of our service was unhealthy, we would log into that machine and see what was going on and check the logs and see what we could do. Now, if you have an unhealthy instance, you kill it and another one pops up. So we like to say it's let's use goldfish instead of thoroughbreds. The goldfish would be these things that we can kill, another one pops up, and the thoroughbreds would be this big server that we have to go in and debug and diagnose and see what's going on so our application runs well again. So the fact that we don't have to do that anymore is great, but we also need to be educating our DevOps teams that there's no need to go in and modify or connect to a remote pod in a container. Okay, so we talked about the good things. What are some of the challenges? First of all, what container runtime are you going to use? And I think most people will say, well, Docker. Docker's the only one there is, right? No. There are other options, and Docker is a popular one, but this is something that needs to be considered very carefully, because Docker tends to be very bloated. There's a lot of things from a security perspective that you would be concerned about by having unnecessary things in your container image. So you might want a more sleek down version of that, and there are other options to consider. What's going to be your registry? Is it going to be Docker Hub? Is it going to be something on-prem? Is it going to be one of the cloud providers? What are some of the features and functions that they provide that might be useful to you? What are you going to do about security? Not only in your cluster that's running all these containers, but what about in the containers themselves? So how are they secure from intruders or any malicious attacks? How are your containers going to network and communicate with each other? That's a big decision. So there's a lot of different options there. None of them are actually simple, but very important thing to consider how these guys communicate with each other. How do they discover one another? So I have thousands of services, and we showed the guilds versus the friends versus the leaderboards. How does the friends find the leaderboards? How does the guilds find the friends? That discovery mechanism is an important piece. What do we do about persistence? The fact that these are ephemeral in nature means that any logs that I have on that instance in that container could go away at any time. So I hope it's not something that's like financial transactions or account stats or things like that, because I can't keep them locally because they can go away. So what do we do for like a centralized persistence? And the same thing with logging. If I have very much intelligence embedded in my logs, that container could go away at any time. So I need more of a centralized logging approach. And what are my options and how would I implement that? Overall management, it's complicated. So what are we going to do here? There's a lot of questions that we have to have an answer for that are going to impact our architecture. And that's where we start talking about a container orchestrator. There's three mainly. So Kubernetes, obviously all the cool kids are doing that one. So this is, you know, in my opinion, it's not even close. I mean, that Kubernetes has won this battle. Earlier, we had Apache Mesos, which had some, you know, good features, and I think there are some people still using that. And on the right, we have Docker Swarm. So Docker created their own orchestrated software. Very small segment of the market uses that. But I think it's safe to say that we are in a Kubernetes world, and these other two and any others that aren't even on this slide have kind of raised the white flag and surrendered and kind of given in to the Kubernetes. It also helps that it's an open source and a community effort, you know, led by Google, and big sponsorship by Red Hat. And so just the number of contributions to the project are crazy. So that's why Kubernetes has been such a good option and remains strong. What does an orchestrator do? Well, they do the overall management of the cluster. They do things like health checks and automatic resolution when things aren't healthy. They scale up or down depending on load. They ensure actual state equals desired state. This is pretty neat. So imagine before we had this, I'm older than I think probably everybody on here, but imagine when we had to worry about creating this ourselves, where you would say, I need to always have certain amount of horsepower available. And in the case of our microservices, I need to have 10 instances of the credit card checker always running. So in Kubernetes, you just say, I need this to be 10, and it's Kubernetes' responsibility to always make sure that's 10. So if two of them go down within seconds, and like 3 or 4 seconds, 2 others will pop up. So pretty cool from an architecture standpoint and feature function. It pulls updates from an image repository. So it recognizes that there are changes, and it will pull the updated version and deploy it with a rolling update with 0 downtime. So again, without something like this, it's hard to do yourself, and Kubernetes makes it easy. So I have my updated version of my app. I post it out to my repo. Kubernetes says I got it from here. It spins down the older versions of the app, spins up the newer versions of the app, and then just like that, you have it ready to go with no downtime. If there was a problem after you had the new version of the app out, you could easily roll back to a prior version. It could be the -1 version. It could be the -2. They make it easy. And they do a lot more. So I think from people that don't know much about Kubernetes, when they sit down and they think about all these things that we had to be responsible for implementing on our own without it, It does a lot, but with that comes a lot of complexity. So the challenges with Kubernetes are, number one, it's complicated. So it takes a long time to get going. And let me put this guy up here. There is just so much to it. The second is human resources are scarce. So if tech leaders are making decisions based on purely on technology and feature function, they find themselves in trouble later when they can't find enough qualified resources that can work on it. I have made similar mistakes in my career on different technologies that I thought were superior after a detailed product review, would go ahead and implement that and then could not find qualified resource to work on it, which was my mistake. The ecosystem is overwhelming. So when we start talking about the number of options that are available and the service mesh and the things that you have to figure out and you have to stitch together yourself, those are really, really overwhelming. And there's a funny Dilbert. I need to know why moving to the cloud didn't automatically solve our problems. You wouldn't let me re-architect it, just put it in containers. And then he finally just says Kubernetes. It's hot, there's no doubt about it. This is slightly blurry, but I wanted you to see when we start talking about service mesh. I have do-it-yourself, anyone? I mean, look at the number of options. You know, coordination and service discovery. You know, service management, scheduling and orchestration, container runtimes, cloud native networks, CICD software solutions. So when you think about the number of things that you have to get working together, it's daunting. And not only do you have to choose them because you're going to need these, but you have to get them working together. And most of these are open source. And then how do you manage the updates and security patches and inconsistencies or incompatibilities with one version of a component with another? That's when people are tech leaders are throwing their hands up and saying, I need some help here because this is just too much for me to take on. I bit off the Kubernetes stuff, but you know, trying to get all this working together and providing this service mesh that I need some help. So that's where the cloud vendor options come into play. Let's start over here at AWS, Elastic Container Service. So if you just want to run your containers and let Amazon do some simple scaling up and some scaling down, don't need Kubernetes for that. That's the ECS service. By the way, the game that I mentioned, Anthem, with the millions of containers, we used ECS. We did not need Kubernetes, so that was the Elastic Container Service we used for that game, which they still use now. If you want to use Kubernetes, Amazon has Elastic Kubernetes Service. So they choose some of those mesh items for you, and then they claim to make it easier, which they do. It's still not easy, but it's easier. And then they have Fargate, which is, you know, a combination of some on-prem versus public cloud, and really insulate you from the infrastructure of Kubernetes. And they call this a serverless approach, which it partly is, but you can see that what they're trying to do here is make things easier for you by taking away the complexities and the reasons that you're struggling. Excuse me. We go to Azure, and they have container instances, which are very similar to ECS. They have their Azure Kubernetes service, very similar to EKS. They also have Red Hat OpenShift, OpenShift container platform on Azure. Red Hat solution is pretty robust, not cheap, but takes a lot of the uncertainties and decisions away from you and says we'll handle the service mesh for you automatically. Then Google has their equivalent, containers on compute, Google Kubernetes Service, GKS. Everybody seems to have a KS, don't they? And then they have their Anthos, which is a pretty awesome on-prem versus public cloud solution that is gaining some traction. And then IBM has IBM Kubernetes Service, IKS. and Red Hat OpenShift Kubernetes service, which they call that ROCs. So they call it ROCs on IBM Cloud, and some customers are finding that an attractive option, although it is very expensive. So you can see, as a tech leader, someone says, hey, I want to run my containerized application in the cloud. What are you going to do? There's a lot of options here, and how long is it going to take us to go through all these? And if we're an AWS shop, we're down to 3 options. Okay, great. But maybe we haven't even chosen public cloud yet. So maybe we want to choose the public cloud based on our workload profile and which one could run our containerized app the best. Bottom line here, the race is on. I mean, look at these guys. They all have a KS. They all have similar offerings. They're one-upping each other every day. This is a very big billions and billions of dollar market. And so they're competing, and they have a lot of resources dedicated to trying to win this. Here's an AWS Marketing email I received yesterday. I thought I would share that. You can see what they say about Amazon EKS. Highly secure, multiple availability zones, replaces unhealthy control plane nodes, serverless compute with Fargate, built with the community, the fact that AWS actively works with the Kubernetes community. I get these a lot. I'm sure many folks here do too. But it's interesting to see what terminology they use and what bullet points they hit to try to sell us on their Kubernetes service. What about vendor lock-in? So we just saw a lot of different cloud provider options. What if I'm concerned and I don't want to be tied to any particular cloud provider? So in search of write once, run anywhere, which is a very popular strategy, if it's possible, many customers desire something like this because they don't want to be tied into any specific implementation if they can help it. So Red Hat OpenShift, which is part of IBM now, IBM paid $34 billion pretty much just for OpenShift. So which tells you the importance of the container movement to IBM. And they have an implementation that can run anywhere, either on-prem or in any of the public cloud providers. When I say any, I really mean 4, Azure, AWS, Google, and IBM. And they do a good job. It's very expensive and out of scope or past the limit for many customers from their financial standpoint. Then we have Pivotal. VMware purchased Pivotal about a year ago, I think, $2.7 billion. So a little bit better deal than OpenShift, but also you can tell how the VM folks at VMware are recognizing that people are going to containers here. We need to get a play in this space, and so they bought Pivotal. Rancher is the other one, excuse me, and that was recently purchased by SUSE for $600 million. Now, Rancher didn't compare very well in feature function to the other two, but it was an option for shops that had a tight budget that didn't need all the bells and whistles of like an OpenShift, and they just wanted some help managing some of the complexities with Kubernetes. Now, we say write once, run anywhere, and you're using one of these probably to avoid vendor lock-in, but the big secret is then you're going to be locked into OpenShift, or then you're going to be locked into Pivotal. Yeah, you're not locked into a cloud provider, but you're locked into your container orchestrator. So that's kind of like some politics being played, but you can choose where you're going to be locked in. You just have to choose it carefully. Okay, let's take a right turn down this path and see how the serverless solutions are going to stack up to our container implementations. This is one of my favorite graphics, Leonardo here. So I deploy my app on serverless, and now somebody else has to manage it, and he's laughing uncontrollably. The thing that's so funny to me about this is it's true. So we're going to talk about that now. Serverless, also known as functions as a service. They are event-based execution for your code. You pay for each one of those executions. So we'll talk about where that makes sense and where it doesn't. It is literally no ops situation. So all those things that you had to be concerned about in a container and Kubernetes, and granted that some of the cloud provider solutions take some of that away from you, they're in a serverless environment, it's gone. And the exact same application code as was in the container image. So you take your Python, you take your Go, you take your Java, take your Node, and you can run that in serverless just as you would as if it were in a container image. What are the events to trigger an execution? Well, first, you have forced execution. Hey, run this. Either called by, Ansible script or any kind of automation tool, or by another piece of code. It's called outright. That's the first one. Second, API endpoint is popular. So website or mobile hits API endpoint, that triggers a Lambda execution, does something on database, returns a return code and a result set. In my opinion, the vast majority of the apps we see today are API endpoint based. So when we talk about, hey, I'm not so sure serverless is a good candidate for many projects, I think it's the other way around, because the vast majority of projects I've worked on have code triggered by an API endpoint. It could be an item in a queue, like the Amazon.com example that I showed, where we have workers that are microservices that are working on items in the queue. A new item in the queue could trigger a Lambda function to go run, and that's exactly what they've done. It could be an event on a stream, it could be a new record in a database, and the list goes on and on. The actual number of events or type of events vary by cloud provider, and in this case, AWS is by far provides the the greater number of events to trigger on execution. And so here's a screenshot I took a little while ago. The interesting thing is, so here I'm adding a trigger to my Lambda. It says, what do you want this to be on? But look at my scroll bar over here, since I couldn't take the whole list. And look how you can just kind of gauge how many events I could actually trigger my Lambda invocation, which is a lot. So pretty robust, and that's where I was talking about. We become the stitchers of these things, and now I just say, hey, I want it to go off an API gateway, off of endpoint, and then trigger my Lambda. And what I do in my Lambda is what I do. Here's a sample serverless CICD for the simpler version compared to containers. So we have my app repo. It does a build. In this case, it generates a artifact, a zip file, and that's pushed to the cloud environment. And there's some other stuff that goes on here, but at a high level, it's pushed to the cloud environment, and my app becomes live. So a little bit simpler than a container. We don't have the concept of a registry, but so in the case of Lambda on AWS or Azure Functions, this is pretty simple. I want us to be able to have some really robust pipelines that we think add a lot of value, and to be able to position those with our customers when we can. But that's a very simple serverless CI/CD pipeline. Where do we use serverless? Amazon Lambda. That's probably the market leader, I would guess, although I don't have the actual breakdown in the industry, but that seems to be, in my opinion, the most robust. At least when I was at IBM, the vast number of customers were using Lambda over any of the other options. Azure Functions. This is coming on strong. This is comparable almost to Lambda. Especially if you're a Microsoft shop, you would use Azure Functions. Google Cloud Functions. So Google Cloud GCP has the same capability with a reduced number of event triggers, but you can run your cloud function in Google Cloud. IBM Functions. They use Apache OpenWhisk, which is an open source serverless behind the scenes is what their implementation of that, but you can run it there as well. Knative is an open source option and is very popular in many of the open source frameworks around containers and serverless. So you'll see that Kubernetes has some Knative capabilities, but it's kind of weird that you have this container infrastructure that you then say, I want to run serverlessly, but I'm maintaining all the servers that do that, which is kind of defies the point. But Knative is a very popular open source serverless project. And then you have open functions as a service. So just because we want to run something serverlessly doesn't mean that we're really limited in where we run it. And keep in mind, these are just 6 that I chose. You know, Oracle Cloud has their options, and so does Salesforce and others. So there's a lot of different places you can run it. I'm working on an article right now where I take the same exact code and I run it in Lambda, and I run it in Azure, and I run it in IBM, and I run it in Google with no changes to the code. I might add Knative to that as well. So if anyone is interested in that, I can show you the repo. I can share the repo with you. But it's pretty interesting that, you know, we talk about vendor lock-in on some things, and I took the same code and I ran it in 5 different places. There are some configuration things you have to do, but the lock-in is really, really kind of light. Not too much of a concern. What are some of the challenges with serverless? Well, first of all, there's an execution time limit. So in AWS, for instance, that's 15 minutes, I think. I don't know about you, but there's very few pieces of code I've written that take longer than 15 minutes. At least the good code that I wrote. It also has an execution size limit. We'll see that in a second. But it actually, most workloads don't really hit either one of these limits in my experience. It can go dormant if not executed. So if you need something that's always 100 millisecond response time, and you can't have like that one time where it takes more than that, that can be a challenge. So if you had a website and it's constantly being hit, and then it goes to sleep because everybody's, you know, gone for the day or whatever, AWS, for instance, will make that dormant, and the first execution of that, the next time will take like 3 times as long. After that, it's hot again. So if you have something that's always on, it's not a problem. Otherwise, people are trying to figure out, and they're writing other code that just wakes the thing up every hour or something like that. So there's easy ways around that. Pay per execution, not wise for certain apps. If you have something that's doing a gazillion events a day, it could be more expensive. And it's harder to do blue, green, and canary deployments. You don't have that kind of flexibility that you have in a container and Kubernetes architecture that you do, that you need. In some cases, you don't need that. Very few applications in my experience are going to benefit from some of these things. But when you need to do a canary deployment, you can do it in a serverless environment. It's just more difficult. Let's look at the pricing. We're almost to the end. Here we have AWS Lambda, and you can see that they have, you know, here number of requests, 0.20 for 1 million, 20 cents for 1 million requests. It's not bad. And then the duration you're billed for based on the memory and how long it takes. So that's a pretty low number there. And then you can see here's the memory price per 100 milliseconds. So they provide everything very transparently. So you can check it out. And so I have the total blocked here, but I put in the calculator. I have 30 million requests. And this is in a month, 30 million. So I say I need 200 millisecond response time, and I'm using 128 meg of memory, the least available I needed. So they show you the formula, and then they show you the price. So for 30 million executions, it's $18. Not bad. So, you know, that's pretty good pricing for getting the automatic scalability that you need. By the way, if you need it to go to 60 million, they ramp up the servers behind that to make it happen automatically. So not having to worry about that for less than $20 for 30 million executions, pretty compelling. Let's compare that to a virtual machine. So let's say I have a container running on a VM. In this case, it's an A1 extra large, which is a big machine. We got 4 virtual CPUs, 8 gig of memory. Number of executions does not matter here because this thing it's always on. I can use it as much as I want. And this price is $46.94 in a month. So almost 3 times that. Granted, it's not completely apples to apples based on number of executions and things like that. But these types of calculations our customers are going through because they know that they can get this thing running multiple ways. What way is going to be the most cost efficient? And at the end of the day, it depends on the characteristics of your workload, how many executions. If you needed a VM image, what would be the size and the characteristics of that? All that comes into play, but they're all going through these calculations to figure out how they can optimize their spend. Okay, when containers, it's executed 1 million times. It requires a lot of memory. 0 latency is required at all times. There are no sleeps of inactivity. Long running execution times greater than 15 minutes. More flexibility with fine-tuned deployments. Blue-green, canary deployments, A/B testing, things like that. My ideas here are machine learning jobs, Hadoop, Spark, the EMR stuff, any ETLs, things that you typically want to do a divide and conquer and have some long-running jobs that do a lot of things that take a long time. That's when I would use a container approach. When serverless, it's pretty much the opposite of those. Code executes in less than 15 minutes, not execute a gazillion times. The event-based API endpoint, the primary one here, but the others are very useful as well. Like, in the old days, we'd have to write some code to actually recognize that there's a new item in the queue and I need to do some work on that. The fact that that's done for you automatically is huge. And also when you're lacking expertise in Kubernetes and containers. So if you had the option and to go either direction, but one required Kubernetes resources and the other didn't, then I would definitely go serverless because it'd be a lot faster without the ramp up time and developers can focus on building their app instead of focusing on infrastructure. Okay, summary, microservices are a solid design architecture. These are not going away anytime soon. In most cases, in my experience, people are trying to figure out how they can migrate a monolithic app to a microservice one to get all those benefits. Many implementation options exist. We went through a few of those today. There is no single way that is the right answer. They can all work with the right resources and the right commitment. But I hope I was able to convey that the tech leaders are struggling with a number of options and when to choose each. Everything from, do I do a container? Do I do serverless? Do I use public cloud providers options? And what are the difference between those? Do I care about write once, run anywhere and not being tied to a particular cloud provider? Oh, but that's going to tie me into them. What do I do about the service mesh? Do I come up with my own or do I rely on somebody else to do that for me? They are overwhelmed, which is good for us at Gap because they need help. But it is pretty daunting out there right now. Serverless is gaining in popularity due to the complexities and the desire for no ops. So we went from having system administrators to DevOps, and that was awesome. And now we're figuring out how we can minimize that and have those folks spend more time on CICD pipelines than they are with managing Kubernetes clusters of containers. Okay, 2 good books I recommend. Finish these, I'll give you some more. The first one is the best book on containers ever written by Oliver Leibel, and a really good guy, and he's very responsive on LinkedIn if you have any questions, and he calls out the good, bad, and the ugly, and it is absolutely a must read and my favorite book on containers ever written. And then we have Sam Newman on the building microservices, which is the foundation for all this stuff. Just a classic and a solid book, and I highly recommend that too. And I will leave this with, our customers are drowned in information, but starved for wisdom. And it's going to be up to companies like ours to help provide that wisdom through this very difficult, complex time that they have in implementing these solutions. So when I'm faced with implementing something like this for a customer or for myself or for whoever, I tend to say, what would I do? So I don't know if you guys have this show in Costa Rica and Colombia, but this is a popular show in the States. What would you do? And they would catch people on camera and doing things. But what would you do? And when you think about it that way, you start to put yourself in the shoes of these leaders that I can tell you the answer, they don't know. And so that's why they reach out to us and companies like ours to find out how they can get some of that wisdom that they're so desperate for. Questions?
One question, is there any situation in which you would consider running an application as a monolith or directly on a virtual machine instead of like separating these through microservices or serverless?
If I would leave it in virtual machines, basically,
Yeah,
yeah.
yeah.
I think if I didn't need the features and functions that come with that greater flexibility, if it's not updated a lot, if the code isn't changed, if I don't need fancy deployments, if I can have downtime for the application, I would leave it in a VM. I am not a believer in changing things to change them. I mean, if it's working and everything's fine, and it's not needing those features, leave it alone.
Okay, cool.
Question.
Yep.
What is your opinion or the best way to do a transition between monolith to a microservices? Because right now, for example, we are like the first slide you show, like we are trying to split microservices, but we still have a database. But what's your recommendation to
Sure.
do that transition completely?
Yep. So I'm actually working on something for a customer right now to help them with that. But at a high level, there's a thing called a pattern called the strangler pattern, which basically, like a weed on a plant or a weed on a tree, you carve out services one by one, and then those are built on the microservice approach, and then your API router knows to route that to that endpoint. And eventually the whole tree is choked out and all of your stuff is cloud native and in a microservice architecture. But anytime they try to go with like a big bang approach and we're going to rewrite the whole thing and refactor it, and day one it's a monolith and day two it's all new microservices, those fail. So this is more of an incremental approach. Strangler pattern, very popular way to do it. Martin Fowler is very famous for communicating that or designing that pattern. But that's the one I've used, and that's the one I'm recommending to our customers. More of a phased approach, little by little. And one more thing, sorry. The biggest challenge with that, in my experience, is they have the database that is all tied together. So they have to break out some of those tables and put in their own persistence, and that is where they have the most difficulty.
Thank you, Dave. Yeah, I work in the same project that Daniel does. We're like in step one, and one of the things that maybe are difficult for us is the service definition. Sometimes there are like many communication between services.
Yeah.
And we should do it through the API, as you mentioned, and probably start thinking about separating the database. We were doing that, but at some point, because of the rush, we said, okay, let's use the main API for now, and we can break that later. But I feel that that's some kind of tech that we should be solving in the future. Mm-hmm.
Yeah, I would love to talk to anyone who's interested about my view on APIs versus queues, because API-based stuff leads to other challenges. Real quickly, what do you do when the API, your calling is not available, and then things are backing up on you, and then it becomes available, but you can't catch up, Those are things that would benefit from a queue implementation instead of API, but a story for a different day.
What do you recommend in terms of on queues? Like, have you heard about Kafka for managed events?
Yeah, Kafka more for the streaming stuff. For the queue, Amazon, it would be SQS, very, very robust. If you wanted to be more of a open source, you have the RabbitMQ, but then you're managing a RabbitMQ cluster, which is challenging by itself. So I like the cloud provider queue options. They all have one, and they're pretty robust.
Okay, thank you.
Sure.
We have a written question from Joyce. Is there any place where a monolithic app structure makes sense?
Like if you were going to build a new application and you want to make it a monolith?
Yeah, I suppose like if you're building it from scratch, is microservices like a silver bullet for this, or there's a case where you need a monolithic app structure?
No, I can't think of a reason in today's world, if I were starting a new app, that we would say, let's make it a monolithic application. I can't think of one.
Hi, this is Jose.
Hey, Jose.
Thank you for sharing your knowledge. I'm thinking about data consistency when you split the databases and have different microservices accessing different pieces of data. Do you think we should spend time ensuring this data consistency, or is this something that we should try to, split and separate the entities or the models that each microservices serves on their API endpoints?
Yep, that's a great question, Jose, and I think that's where a lot of people are going to struggle, because there is no consistency or RI integrity across structures or across services, right? So a completely different mindset versus, hey, I need to make sure that like my friend is in a valid guild and stuff like that. You still have that capability, but the way that you do it is different. You have to go through that guild service to keep them consistent. And that way, the guild service says, I'm in charge of the guild data, and I always make sure that it's consistent because I'm the one that manages that. So that's a different mentality on how we've been developing systems for a long time, which we have this big Oracle or SQL Server or MySQL database. We have a bunch of tables in there, and they have relationships to other tables and constraints and those things. And that's the monolithic way that is not working well for the new approach.
I see. Let me ask one more, sorry. And do you think events could be a solution for example, when you talk about the friends microservice, let's say we deactivate one of those, should we, could a solution be exposed, like publish an event that the friend was deactivated so the other microservices can do something with their data, with their databases?
Well, it depends on how you would design the app. One of my favorite examples is if you've ever gone into Netflix and scrolled down, it happens rarely, but it does. There'll be a tile that will be blank. It'll be black. That thing is not available. And so the good news is it's not impacting the other things that are available. But so they design it where it's isolated, but the app continues to run without it. And so how much you need that in an application has got to go in the design process. And you might say, hey, if our friend service is down, we cannot create guilds because guilds are made up of friends. So then you would design, well, what do we do for the guild service when friends is down? Things like that. Now, the good news is with things like Kubernetes and serverless, the odds of it being down are really low these days because we're always on. We have rolling updates. So I mean, if the number of things that are available are not what it's supposed to be, then we have some major problem. But the downtime, I agree that you need to account for it and design your application for it. The good news is it's not happening very much anymore.
I see. Great, thanks.
Dave, one more thing. I was thinking about security. Is there a way, or these services come with some kind of security? Like I don't want to be charged because my site was attacked, my app was attacked, and the API was coming up. Is there something that they have to prevent that, or to check that, or to alert me from something like that happening?
Well, I know that the cloud providers have like some of their advisors, right? Security advisor stuff that will inspect. I think it's called security inspector or something like that. I mean, we all know that we could architect and have a working app in AWS. It's wide open to the public, and that would be create some problems possibly. So we have that power and the capability to create it like that, but it also goes into some best design principles on how would we make sure that it was secure. If you believe in the DevOps has moved to SecOps, where security is now shift left, and every developer is responsible for security implementations in their deliverables. I totally agree with that. So it's part of like code reviews and check-ins, that it is inspected for security best practices as well. And so, yeah, I think that you can, there are a lot of tools that are going to help you, but you could still design it poorly and be insecure if you wanted to be.
Got it. Thanks.
Did you guys, did I adequately convey the difficulties around managing a Kubernetes environment?
Yeah, definitely.
Awesome. Well, please feel free to reach out to me. I love talking about this stuff, and look forward to hearing from any or all of you to talk about this or anything else.